So in this lecture, we'll try to understand about waveguides. Now, before teaching you about waveguides, we need to understand a bit more about the waves that we know. So we'll discuss about the waves. So consider a 1D wave. So you write y is equals to a sine. Okay. So you have a omega t and you have a kx. So this is what you say, it's a 1D wave. Now let us try to understand what this wave equation actually says. So before understanding, let us draw a diagram of a wave. So this is what you say. So whenever you see inside the sign, the one which is multiplied with the k is the direction in which the wave is moving. So this direction is x in which the wave is propagating. Now the velocity with which the wave is propagating is always the one which is multiplied with t, that is omega, divided by the one which is multiplied with the x, that is k. Now what is y? Y is actually the vibration about the y-axis. So for example, the maximum vibration that the wave can take is the value of a. So a here is the maximum vibration. So what does wave equation says? Now so what is this y? Y is just the displacement of the particle from this position to the upward position. So y is actually y is equals to a sine omega t minus kx is actually telling you about the fact how high at a particular x the object is. So for example, consider if I consider a distance of x at particular time t, then y will tell me at particular time t the object at the distance x how high it went. Similarly, consider another distance x dash, okay, in time t dash. So the y will tell me at time t dash how high or what is the displacement of the particle from its mean position. So why I'm saying different times? Because the waveform changes with time. For example, um, so say the wave started with a sine. Okay. Now after some time the wave can become like this. So the same wave can become like this after some time. So the same wave equation can be used to say the same thing. So consider a particle here. Agreed. So by using the wave equation, if we know at what distance the particle is, okay, from the origin, so this is my y and this is my x, then I can exactly tell the displacement of the particle at any time t. So this is what 1D equation tells you. Okay. Now little bit more. In 1D equation you have something called a standing wave. So standing wave, so you have seen you have read about standing wave in your plus 2. So this is how a standing wave looks. And how do we find a standing wave? So what you need to do is you need to first write what is the equation of the wave when you go towards the positive x. So remember, when you go towards the positive x, always put minus kx. So what is the equation? So these are the tricks that I'm saying. So the equation will look like a sine, okay, since it is going towards the positive x-axis, so put a minus kx. Agreed. So this is just a trick. Now the another wave, it travels in the opposite direction, so in the negative x direction. So the other wave will be, so let me write, this one is y1, this one is y2. So the other wave will be with a plus sign because it is going towards the negative x direction, so you need to give a plus sign. This is just a trick. Now what is standing wave? Standing wave occurs when these two waves interfere with each other. Then mathematically, when these two waves interfere with each other, it means you need to add y1 with y2. And what is the form of standing wave? So this is the form of standing wave. So what happens in a standing wave? The space part and the time part, they get separated. So this is all about the 1D wave. So this is all about the 1D wave. Now in the next lecture, we'll study about the 2D wave. Agreed? So why are we studying this wave equation? Because we need to understand waveguides. So these are the prerequisite. So in the next lecture, we'll study about 2D waves.